So in this section, we will focus on system parameters. System parameters. So every vibratory system has following three parameters. So every vibratory system has these three parameters. First one is inertia. Second one is restoration. And third one is damping. Now, in this lesson, we are going to learn about the first parameter, that is inertia. So inertia is the property. Inertia is the property due to which a system resists the change in its state either of the rest either of the rest or motion. So inertia is a property of the system, and it can be like it can occur due to two things. First one is due to translation mass, and second one is due to rotation. So there is a distribution. So there is a distribution of mass about the axis of rotation. So second moment of mass about axis of rotation. So second moment of mass about axis of rotation. So we can also call it mass moment of inertia, about axis of rotation. The axis of rotation is called the polar axis. The axis of rotation is called the polar axis. So let's study about second law of motion in this case. So second law of motion. So there are two cases. First one is in pure translation. So pure translation, and second case is pure rotation. Pure rotation. So in pure translation, we are going to represent inertia force by this expression. Inertial force Fi is equal to mass into acceleration, which is given by the double integral of the displacement. So m x double dot. Here Fi is the inertia force. Now in case of pure rotation, we are going to use the expression Ti dot I, which is the moment of inertia, dot alpha, which is angular acceleration, which is the double differentiation of the angular displacement, theta. So here Ti is the inertial torque. So the mass moment of inertia of a body about the axis passing through its center of mass is always minimum. So let me write it, otherwise you are not going to take it down. Yeah. So the mass moment of inertia of a body about the axis which is passing through its center of mass is always minimum. Now let me talk about the parallel axis theorem. Okay, let me read this thing first. So the parallel axis theorem. Now suppose there is any body here, and there is one axis which is passing through its center of mass. So this is one axis which is passing through its center of mass here. So this is center of mass, and there is another axis which is passing through the hinged part here, and the distance, let's call it xx, and the distance between these two, so this is the, we can call this is the axis of rotation. So this is the axis of rotation. So the distance between these two axes is given by A. So in this case, we know the moment of inertia about the center of mass, and we need to find out the moment of inertia about the axis of rotation, that is axis. So we need to find out. So we can say that the inertia about the axis of rotation is greater than the inertia of the axis passing through the center of mass. So we can calculate the I-axis by using this expression, that is I-axis equal to the inertia of the center of mass plus mass of the given body multiplied by A. So here the moment of inertia about axis can be calculated by this equation. So finally we can write this equation as okay. So this is the final expression for calculating the inertia about the axis. Now suppose we want to calculate the same thing. Just let me change this thing. Okay. Now suppose this is the x1 axis and this is the let me erase this thing also, sorry. So this is the axis passing through center of mass of the object lying here at this point. So, and the distance between these two axes is given by b, distance b. So in this case the inertia about x1 axis is known to us, and we don't know about the inertia about center of mass. We have to find out the value of this thing. Now we know that here the inertia about x1 axis is greater than the inertia about center of mass. So we can calculate by the expression ICM, that is inertia about center of mass equal to I xx1. Let me do it from basic, otherwise you will be getting confused. So we know that the inertia about x1 axis is given by Ix1 is equal to ICM plus MB dot B. So we need to find out the value of this thing. So we are going to bring this term here, and or we can bring this total term to this term to here left hand side, and we are going to get the expression ICM is equal to inertia about x1 axis minus mb square. So this is our expression for this case.